So we're going to look at writing chemical formula for different compounds, for binary ionic molecular compounds, also some ternary and some oxyacids, and we're going to learn how to name each compound. Now, naming is extremely important because oftentimes when you want to talk about a chemical reaction material, you got to use the name of the material. Uh, so we're going to look at different classes of the material, and then we're going to look at how to write their chemical formula, balance the charge, and then once we learn how to write their chemical formula, we're going to look at the naming for these compounds. Now, so in this chapter, we're going to start with showing you the difference between common and systematic names. We're going to show you how ions are formed and how we can name individual ions. And once we learn how to name individual ions, we're going to put cations and anions together, form binary ionic compound. We look at their naming. So binary ionic, binary molecular, and then we're going to look at some acids. We're going to start with binary acids, and then we move on to oxyacids. So there are two ways of naming compounds, different compounds. One is the common name, which common name usually represent some characteristic or properties of a compound. For example, this dinitrogen monoxide, it's called the nitrous gas, or it's called the laughing gas. But as you see, if we want to use the common names for every single compound, it becomes very hard to memorize just the names and the formulas for each compound. So what we are more interested in this class is finding a systematic way of naming. Systematic way of naming makes it easier, at least, to know what the formula of each compound is if the name is given to you. So naming can get a little confusing. So we're going to look at the naming of different materials, and we're going to classify these materials into two groups. We're going to look at binary compounds and also ternary compounds. So binary compounds are any compound that's composed of two elements. So binary means two. So binary compounds are composed of two elements. And ternary compounds are composed of three elements or sometimes more. So in terms of binary compounds, we're going to look at binary ionic and binary molecular compound. And once we learn writing the formula and naming for binary compounds, we look at polyatomic ion and some ternary and quaternary material. Now, before we get into looking at compounds, let's review how we name every element and every ion. And once we know how to learn the elements and ions, then we can put the elements together, ions together, make binary and ternary compounds, and then we can look at their naming. So in terms of the elements, just the elements, we had to memorize the first 56 elements. So the element symbol is given in the periodic table, and you're supposed to memorize the name and symbol for each element. Now remember that elements in the periodic table are monoatomic except for hydrogen, oxygen, nitrogen, fluorine, chlorine, bromine, and iodine. In elemental form, these come as diatomic molecules. And we also have two more exceptions, sulfur and phosphorus. Sulfur in an elemental form is always S8, and phosphorus in an elemental form comes as P4. Now, knowing what elements are monoatomic, which ones are diatomic or polyatomic, this is important when we start writing chemical equations. So in a stable form, Hydrogen, oxygen, nitrogen, fluorine, chlorine, bromine, and iodine are diatomic. Sulfur is S8 and phosphorus is P4. Any other element on the periodic table is monatomic. Now, oftentimes, elements form ions in order to form ionic compounds. Now, formation of ions is done through the transfer of electrons. So if the element, neutral element, loses electron, it forms a cation. Cations are species that have a positive charge on them. So losing of electrons result in a formation of cations. And also remember that cations have positive charge on them. So here, for example, magnesium is losing 2 electrons. It becomes magnesium 2 plus, which is a cation. Or aluminum loses 3 electrons and it becomes aluminum 3 plus, which is also a cation. Now, how do we distinguish between the element and the ion? So let's look at the naming for cations. So to name the elements, we already know. So K, with no charge on it, just the element, is called potassium. But if there is a positive charge on potassium, this becomes potassium ion. So for cations, you use the name of the element followed by the name ion. Now, magnesium in an elemental form, no charge on it, neutral, is just called magnesium or magnesium metal. Now, if magnesium loses 2 electrons and becomes magnesium 2 plus, now it's called magnesium ion. Aluminum in an elemental form is just called aluminum. When it loses electron and forms cation, it becomes aluminum ion. So it's very important that when you have an ion, when you have a cation, you use the word ion followed by the name of the metal. Otherwise, what you're calling does not represent a cation. Now, let's see how we name anions. Anions are formed from gaining of electron. For example, chlorine, if it gains electron, it becomes chloride ion. So gaining of electrons results in the formation of anion. Anions have negative charge on them. So naming the anions is different than naming of the cations. So for anions, in order to name them, you use the stem of the nonmetal name followed by IDE. So fluorine as an anion becomes a fluoride. Chlorine becomes chloride. Bromine becomes bromide. Iodine, iodide. Oxygen becomes oxide, and nitrogen becomes nitride. And since these are still ions, you use the word ion after it too. So this IDE, this suffix, this represents the anion of nonmetals. Now let's see what elements in the periodic table would form cations and what elements form anions. We will also learn to predict the charges of some cations and anions. Now, all the elements, all the metals form cations, no exceptions. The only ion that metals form are the cations. There is no such a thing as a metal with a negative charge on it. So metals form cations, and that include main group metals, transition metals, and rare earth elements. They all form cations, meaning that they all have the tendency to lose electrons and become cations. For some of the metals in the periodic table, we can predict their charge because their charge is fixed. And that only applies, the fixed charge only applies to main group metals. Now, all the metals in group 1A have a 1 positive charge. Group 1A is alkaline metals. Now, all the metals in group 2A have a 2 positive charge. And from group 3A, only aluminum has a fixed charge of positive 3. Gallium, indium, and thallium, they can have positive 3 charge, but they can have other charges too. Now, the general rule for only main group elements is that the group number equals to the charge of the cation. So group 1A, all the metals and also hydrogen, they have a 1 positive charge. Group 2A, 2 positive. Group 3A, aluminum is positive 3. The rest of the metals, which are gallium, indium, thallium, they can have a positive 3 charge, but they can also have other charges too. So these fixed charges for main group metals, memorize them. So what you need to memorize is that all the elements in group 1A, their charge is positive 1. All the elements in group 2A, their charge is positive 3. Group 3A, aluminum is always positive 3 and only positive 3. Gallium, indium, and thallium, they can have positive 3, but they can have other charges as well. Now, transition metals, which are all those elements you see in yellow, they have variable charges. The charge of the transition metal is not fixed. So I can't tell you for sure what the charge of chromium is. I know what possible charges chromium can have, but depending on the condition of the experiment, depending on what anion it mixes with, depending on the stoichiometry, many factors, the charge of the chromium could be, it could be chromium 3, it could be chromium 5, it could be chromium 7. So just know for now that transition metals have a variable charge. Their charge is not fixed. Later on, I'll show you how you can find out what the charge of the transition metal is if the formula is given to you. So the charge for rare earth elements also is variable. They don't have a fixed charge. So now let's look at the anions in the periodic table. Let's see which element form anions and also how we can find the charge of the anions. So nonmetals form anions. So nonmetals, when they form ions, they would form anions. Now, how do we find the charge of an anion? The charge of an anion, you can find it by group number minus 8. So all the nonmetals from actually carbon is a nonmetal, nitrogen, phosphorus, oxygen, sulfur, selenium, fluorine, chlorine, bromine, iodine, and the last group, group 8A, are transition metals. So carbon, we're not going to talk about carbon. The charge of carbon is different. We'll talk about carbon later on. But from nitrogen and phosphorus, we can look at the charge of nitrogen and phosphorus when they form anions. So nitrogen and phosphorus are in group 5A. So for their charge, that's group number minus 8. So the charge is negative 3. So in here, bismuth and antimony do not consider a nonmetal, so they're not going to have a negative 1 charge. Remember that although we're talking about groups, but we're looking at only nonmetals in each group. So nitrogen and phosphorus, they're always negative 3. Arsenic is a metalloid. It can have a negative 3 charge as well. But antimony and bismuth, those are metals, so they don't have a negative charge. Those are post-transition metals. Now, group 6A, oxygen, sulfur, and selenium, and tellurium 2, they have a negative 2 charge, so 6 minus 8, they have a negative 2 charge. Polonium 2. And then you get to group 7A, which are the halogens, their charge is negative 1. So these charges are also fixed for nonmetals. So you need to memorize the charge of the nonmetals based on their group number. So you look at the periodic table, see what group they're in, and you memorize their charge. So know that nonmetals form always only anions, and their charge is basically group number minus 8. So here, group 8A, which are the noble gases or inert gases, keep in mind that they don't form ions. Why? Because they're inert gases. They don't participate in any transfer of electrons. They don't undergo any transfer of electrons. So you won't expect to see a charge on noble gases at all, ever. So any metal should have a positive charge if it is in an ionic form, and nonmetals should only appear as anions. So let's see how we can form ionic compounds by putting a cation and anion together. So ionic compounds are compounds that contain both cations and anions. So basically, ionic compounds are composed of a metal and a nonmetal, because your metal is gonna form the cation and the nonmetal forms the anion. And if you only have one metal, one nonmetal, this becomes a binary ionic compound. So an example of ionic compound is sodium chloride here, NaCl, which is the table salt. Now, a couple of things to know about formula of ionic compounds. First of all, when cations and anions come together and form ionic compounds, the ionic compound does not have any charge on it. So in order for ionic compound to be stable, it has to be neutral. So no charge on the ionic compound. The net charge is 0. These are some examples of ionic compounds. So we can have a combination of any cations and any anions. And what I want you to pay attention to here is that the formula of the ionic compound here does not have any charge on them. So meaning that when we write the formula of this ionic compound, we gotta look at the charge of the cation, charge of the anion, and balance out the charges. So the ionic compound itself has a net charge of 0. I will show you how to balance out the charge of the cation and anion in the next couple of slides. So let's look at writing chemical formula, for example, for a compound that's composed of barium ion and a nitride ion. Now look in the periodic table and find barium. Is barium a metal or a non-metal? It's a metal, very good. What group is barium in? 2A, very good. Would you expect barium to form a cation or anion? Cation, very good. Now, what would you expect the charge of barium to be? +2, very good. Now, let's look at nitride. Is nitrogen a metal or a non-metal? Non-metal, very good. Would you expect it to form anion or cation? Anion, very good. Now, nitrogen is in group 5A. What would you expect the charge of nitride to be? -3, very good. Now, we want to write the formula of ionic compound that's composed of barium ion and nitride ion. So to write the formula of ionic compound, you first always, when you write the formula, you first write the formula of cation. So first comes the cation, then the anion. So meaning that in order to write the formula, I first write the cation and then the anion. Now, the second step in writing the chemical formula for ionic compound is balancing the charge. Balancing the charge meaning that you want the net charge on the ionic compound to be 0. Now, barium nitride in a ratio given here, 1:1, the net charge is not going to be 0, right? Because barium is 2 positive, nitrogen is 3 negative. So the net charge, if I use 1 barium, 1 nitride, is going to be -1. So that's not going to work. So we want to change the number of cations and anions in a way that at the end, the net charge on your ionic compound is 0. Now, when you do that, when you adjust the number of cations and anions, keep in mind that you always have to have the whole number. You can't have fractions. So, barium is 2 positive, nitrogen is -3. Now, if I use 3 barium and 2 nitride ion, then my net charge on this compound is going to be 0. Let's see how. So you have 3 bariums, 3 positive 2 is +6. 2 nitride, -6. This becomes a 0. Now, how do I show that in my chemical formula I need to have 3 barium, and 2 nitride ions. So you're going to use subscripts to represent the number of each ion you have. Now, since I needed 3 barium, barium has subscript 3, and I needed 2 nitride, so nitrogen has a subscript of 2. Now, this is the ionic compound, and this is the correct formula of the ionic compound that's composed of barium ion and a nitride ion. So remember, the subscripts are used in order to balance the charge. Subscripts have to be whole numbers, and then the subscripts has to be the smallest actually whole number. Now, to find the smallest whole number when it's not easy to tell what it is, the best thing would be swapping the charges. So the charge of nitrogen is 3. I gave the subscript of 3 to barium. The charge of barium was 2 positive. I gave the subscript of 2 to nitrogen. This is the shortcut you can use in order to balance the charges for ionic compounds. After you write the formula of ionic compounds, always double check. Make sure that the formula that you're reporting, actually the net charge on that formula is 0. Now let's see how we name this ionic compound. So the rule for naming ionic compound is that you first name the cation followed by the name of the anion. So this compound is called barium. The name of the cation, I'm using barium, and the anion is nitride. So this is called barium nitride. So let's look at another example. You want to write the formula for magnesium oxide. This is how you want to approach this. Magnesium oxide, it's a compound that's composed of magnesium and oxygen, right? That's what the name represents. So it's a binary compound. What type of binary compound? Metal, non-metal? It's an ionic binary compound. So binary, ionic. So by just looking at the name, I can tell it's an ionic compound composed of a cation and anion. Now, magnesium oxide composed of magnesium, metal, and oxygen. Now, since it's an ionic compound, metal, non-metal, we gotta find out what the charge on magnesium and oxygens are. Now, look at the periodic table and find magnesium. So magnesium is in group 2A. What charge would you expect magnesium to have? Very good, 2 plus. Now, oxygen is in group 6A. What charge would you expect oxygen to have? -2. Very good. Now, in order to write the formula for this ionic compound, I first write the cation, which is the magnesium, and then the anion, which is oxygen. Now, second step is balancing the charge in between magnesium and oxygen. So as written like this with 1:1 ratio, let's see how we're doing on charges. So I have 1 magnesium, which is +2, 1 oxygen, which is -2, and it's already 0. So we want 1 magnesium, 1 oxygen to make magnesium oxide. So this is going to be the formula of magnesium oxide. Now keep in mind that if you only want 1 of each element, we don't write the subscript 1. Any subscript that more than 1 is more than 1, we write that down, but when it's 1, we don't write it. We don't write it, but it's still there. So let's review naming of binary compounds. So we just looked at binary ionic compounds. Those are the compounds that are composed of a cation and anion, or in the other way of saying it, one metal, one non-metal. So if you have a binary compound where your cation is a main group metal cation, in order to name that compound, you start with the name of the metal followed by the name of the anion. Now, in terms of metals, in the periodic table, we have transition metals, we have rare earth elements too. So transition metals and rare earth elements do not have a fixed charge. So we're going to have to look at the binary compounds where your metal is a transition metal and it can have multiple charges. So again, in order to write the formula of ionic compound or to name them, we first write the name of the cation followed by the name of the anion. And remember, for the anion, the suffix always ends with IDE. Let's do more practices. So we want to name this compound. The way you want to approach this is that, first of all, you want to know what type of compound is it. Is it ionic or not? So since this is composed of a metal and non-metal, it is ionic. Now, your metal, is it a main group metal or a transition metal? Magnesium is a main group metal, so it means that it has a fixed charge. So in order to name this, you first name the cation, which is magnesium, followed by the name of the anion, which is going to be magnesium boromide. Now, just as extra practice, let's see how we write the formula for magnesium boromide. It's given to you, but let's make sure we know where it came from. So magnesium boromide is composed of magnesium ion and boromide ion. Now, in the periodic table, find magnesium. Magnesium is in group 2A. What would you expect the charge of magnesium to be? Positive 2. Very good. Now, boromine is in group 7A. What would you expect the charge of boromide ion to be? Negative 1. Very good. Now, in order to write the formula of compound that's composed of magnesium ion and boromide ion, we first write the metal, which is magnesium, and then the non-metal, which is boromine. Now, we got to balance the charge between these two to make sure the ionic compound is neutral. Now, if the ratio is 1 to 1, 1 magnesium, 1 boromide, do you think this is chargely balanced? It's not, because magnesium is 2 positive, boromine is negative 1, so the net charge is a positive 1. But in order to balance the charge, how many boromide ion do you need? 2 of them, right? So the 2 appears as a subscript here. Now, after you write the formula, you always have to double check to make sure you got it right. Now, to double check, I have 1 magnesium, positive 2. I have 2 boromines, each one of them negative 1, which gives a negative 2. So this is the correct formula of magnesium boromide. So let's look at another example. Now you want to provide a formula for sodium oxide. So sodium oxide is an ionic compound. Why? Because sodium is a metal, oxygen non-metal. By just looking at the naming, I can tell that it has the format of binary ionic compounds too. It's the name starts with the metal name followed by the anion name. Now, in order to write the formula, we know that sodium oxide composed of sodium and oxygen. Now, find sodium in the periodic table. What would you expect the charge of sodium ion to be? Positive 1, very good, because sodium is in group 1A. Now find oxygen in the periodic table. What would you expect the charge of oxide ion to be? Negative 2, very good. Now to write the formula, you first write the metal and then you write the non-metal. So in order to balance the charge, which is the next step, so since oxygen is 2 negative, you need to have 2 positive charges to balance the negative 2 charge of the oxygen. So you would need to have 2 sodium here. And in order to show that you have 2 sodium, you use subscripts. Now, after you write your formula, before moving on, you want to double check and make sure that charge-wise, this formula, this compound is neutral. So based on your formula, you have 2 sodium. Each one of them is positive 1. And you have oxygen, which is negative 2. So this is positive 2, negative 2. It is 0. So this is the correct formula of sodium oxide. So let's look at another example. You want to name this compound Al2O3. Is this an ionic compound? Yes. How do we know if it's an ionic compound? Very good. It's composed of a metal, aluminum, and oxygen nonmetal. Now, aluminum is a main group metal, which has a fixed charge. Now, how do we name ionic compounds where the metal is a main group metal? Remember the rules. You start with the name of the metal, your cation, aluminum, followed by the name of the anion, which is oxide. So the name is aluminum oxide. Now let's review writing the formula for aluminum oxide. So aluminum oxide is composed of aluminum metal and oxygen. Now look in the periodic table. Aluminum is in group 3A. What do you expect the charge of aluminum to be? 3 positive, very good. Oxygen is in group 6A. What would you expect the charge of oxygen to be? 2 negative, very good. Now, in order to write the formula, you first write your cation, which is aluminum metal, and then the anion, which is oxygen. Now, next step is balancing the charge. Remember, when it's not too easy to tell, we're just going to swap the charges. So oxygen is negative 2. I'm going to give the subscript of 2 to aluminum, and then 3 to oxygen. Now, before moving on, we want to double check and make sure that we got this right. So you have 2 aluminum, each one of them positive 3, plus you have 3 oxygen, each one of them negative 2. So this is positive 6, this is negative 6, which gives you the total net charge of 0. So this is the correct formula for aluminum oxide. For example, so you want to write a chemical formula for calcium sulfide. So to write the chemical formula for calcium sulfide, first we want to identify what type of compound we have. So it's a binary compound because it's composed of only calcium and sulfide. And it's ionic because we have calcium metal fluoride, which is a nonmetal. Also, the name represents the format of binary ionic compounds. Now, to write the formula, we know that calcium sulfide composed of calcium and sulfur. Now, look at the periodic table. Calcium is in group 2A. What would we expect the charge of calcium to be? 2 positive, very good. And then sulfur is in group 6A. What would you expect the charge of sulfur to be? -2, very good. Now, next step is writing the formula. So first comes the cation, which is the metal, followed by the symbol for the anion, which is the nonmetal. And now we have to balance the charge. Now, calcium 2 positive, sulfur 2 negative. So it's already balanced. The net charge is already 0. So you have 1 calcium, +2. 1 sulfur, which is a -2. So we want 1 calcium and 1 sulfur in order to make calcium sulfide. All right, so we learned how to name ionic compounds that are composed of main group metal and a nonmetal, and we also learned how to write the formula for those. But let's look at ionic compounds where your metal is a transition metal. Now, the difference here is that transition metals, they have multiple charges, variable charges. So it's important to mention what the charge of the transition metal is. It is important because transition metals in different charges, they have different chemical and physical properties. For example, copper 1 and copper 2. Copper with a +1 charge, usually the compounds from copper 1 are greenish colored. But if you have a copper 2, it's bluish color. So their properties, chemical and physical properties, oftentimes changes. So it's very important when you're dealing with compounds where the metal is a transition metal to mention the charge of the transition metal. So how do we mention the charge of the transition metal? We use Roman numeral to mention the charge of the transition metal. So when you name compounds, ionic compounds of transition metals, the rules are still the same. You use the name of the cation, which is your metal, followed by the name of the anion, except that when you use the name of the metal cation in parentheses, you have to mention what the charge of the metal is with Roman numerals. For example, look at this compound. So in order to name this, this is how you want to approach this. This is an ionic compound, binary ionic. Why? Because you have a combination of a metal or nonmetal. Your metal is iron, nonmetal is chloride. Now, since iron is a transition metal, we know that the charge of the transition metal is important. So to name this compound, we need to know what the charge of iron is. Now, how would I know what the charge of iron is? So by looking at the formula, we don't know the charge of iron. But you know what the charge of chloride is. So you have iron, which we don't know the charge, plus 3 chlorides, each one of them -1 charge, equals to 0. So I'm trying to find out what the charge of iron is. If the formula is just given to me, I'm trying to find what the charge of iron is so I can name it. So iron is a transition metal. The charge of a transition metal is not fixed. So I don't know what the charge of iron is directly. However, I can find the charge of iron in this compound by looking at the charge of the anion. Your anion is chloride. Chloride, the charge is always fixed. It's always -1. Now, so the charge of iron plus 3 negative equals to 0. Now, if the charge of 3 chlorides is -3, that tells you that the charge of iron has to be +3 in order for this ionic compound to be neutral, to have a net charge of 0. So for every single ionic compound where your metal is a transition metal, you need to do this little calculation to figure out what the charge of the transition metal is. So keep in mind that the way you're going to do it is by looking at the charge of the anion, because the charge of anions are fixed. So now that I know the charge of this iron here is a positive 3, in order to name it, you call this iron 3 chloride. So for Roman numerals, memorize 1 through 10. So the symbol for 1 through 10. So let's look at the rules for naming compounds involving metal that's a transition metal or a rare earth element. So in order to name them, you first write the name of the cation, followed by the charge of the cation in parentheses in Roman numerals, and then it's followed by the name of the anion, which ends with IDE. So these are some examples here. So copper +1 is called copper 1, copper 2, iron 2, iron 3. So there are some classical names for these compounds too. I really don't need you to memorize this, but just look at them. When you see them, know where they come from, but you're not required to memorize the classical names. Just the IUPAC systematic naming is enough. So tin and lead are also post-transition metals. They have variable charges. You can have tin 2, tin 4, lead 2, and lead 4. So let's do a few examples here. You want to name this compound FeS. So this is how you want to approach naming this compound. First of all, this is an ionic compound because it's composed of a metal and a non-metal. Now, what type of a metal? We're dealing with a transition metal, meaning that the charge of the transition metal is going to be very important in the naming. So the most important thing here is finding the charge of your transition metal in this ionic compound. Now, iron can have multiple charges, but how do we know the charge of iron in this particular compound? So the way to find the charge of iron is by looking at the anion, all right? So based on the formula, you have 1 iron plus 1 sulfur, and sulfur is in group 6A, so the charge of a sulfide ion is 2 negative. That equals to 0. So you have a 2 negative charge from the sulfide. That means the charge of your iron in this compound has to be positive 2 for this compound to be chargedly balanced. Now, how do I name this compound? I first name the metal, which is iron. Since it's a transition metal, I gotta write the charge of the transition metal, which is 2 sulfide. And we read this as iron 2 sulfide. So let's look at another example. You wanna name this compound here. So this is how you wanna approach this. What type of compound? It's ionic because it's composed of a metal and a non-metal. Now, what type of a metal? A transition metal. Chromium is a transition metal. And remember, for transition metals, the charge of the transition metal is very important. So before we name this, we gotta find out what the charge of chromium is in this compound. Now, in order to find the charge of the chromium, you're gonna look at the anion here. So based on the formula, you have 1 chromium plus 3 chlorines. Each chloride ion has a negative 1 equals to 0. So the charge of 3 chlorides is negative 3. That means the charge of chromium has to be positive 3. That way, this ionic compound is chargely balanced. The net charge is 0. So how do we name this? Chromium 3 chloride. So let's look at another example. You want to write the formula for copper 1 oxide. So this is how you want to approach this. Copper 1 oxide represents an ionic compound because you have copper, which is a metal, followed by a nonmetal, which is the oxide ion. Now, in order to write the formula, we always first write the symbol for the metal cation, followed by the nonmetal. So copper and oxygen. Now, what's the charge of copper? Because copper is a transition metal. For transition metals, always charge becomes important. Now, based on the name, what do you think the charge of copper is? Copper ion. It's positive 1, right? Because in the parentheses, we have 1. So the charge of copper is positive 1. What's the charge of oxide ion? It's always 2 negative. Now, to write the formula, we first write copper, then oxygen. And in order for this compound to have a net charge of 0, you would need to have 2 copper. Now, before we move on, we always double check to make sure that charge-wise this makes sense. So you have 2 copper, each one of them positive 1, plus 1 oxygen, which is a negative 2. So this is positive 2, negative 2 equals to 0. So this is the formula of copper 1 oxide. Now, one thing I want to mention here is that all this work for balancing the charge, the math here, is the scratch work. When I ask for the formula, I just want to see the final product here. In the final product, the formula of your compound, I shouldn't see any charges. So if you write this is wrong. Because in the formula of ionic compound, we shouldn't expect to see any charges. So those are the scratch work. You don't show it on the exam. You just write the formula of the ionic compound. So let's do another example. You want to write the formula for 10,4-fluoride. So to write the formula for this compound, it's an ionic compound. Let's first find out what the charge of each ion is. So 10, the charge of 10 is 4, because the name represents that the charge of 10 is positive 4. And fluoride is a nonmetal group 7A. We know that the charge of fluoride ion is always negative 1. Now, to write the formula, you first write the cation and then the anion. And in order for the charge to be balanced, you're going to need to have 4 fluoride here. Now, to double check, 10 is plus 4. You have 4 fluorine, each one of them negative 1. This is negative 4, positive 4 here. So this is a 0. So this is the formula for tin for fluoride. So we're done with binary ionic. Now let's look at binary molecular compounds. So molecular compounds are compounds that are composed of two nonmetals or even a nonmetal plus a metalloid. So these are the rules for naming molecular compounds. So you write the name for the first element, including the appropriate prefix. We don't use mono for the first element. And then we write the name for the second element, including the appropriate prefix and IDE ending. Now these prefixes from 1 through 10, memorize them. So let's look at a couple of examples and I'll show you how you do naming for molecular compounds. So let's say we want to name this compound P2O5. This is how you want to approach this. This is a binary molecular compound because it's composed of phosphorus and oxygen, both nonmetals, so binary molecular. And remember that for molecular compounds, we gotta use prefixes to name them. So you have two phosphorus, you call this diphosphorus, and you have 5 oxygen, which is pentoxide. So you put them together, you name this as diphosphorus pentoxide. Now, note here that you drop the A or O from the prefix. So I don't call this as diphosphorus pentoxide. So it just becomes pentoxide. So that A, you actually drop it. Now let's look at another one. So CCl4, it is a binary molecular compound because carbon is a nonmetal, chlorine is also a nonmetal, so we gotta use prefixes. So you have 1 carbon, you just call it carbon. We don't say monocarbon because for the first element you don't use mono. And you have 4 chloride, that becomes tetrachloride. So the name is going to be carbon tetrachloride. So let's look at another example. You want to name the following compound, which is SO2. Very good. This is how you want to approach this. So this compound represents a molecular compound because sulfur is a nonmetal. Oxygen is also a nonmetal. And remember, for molecular compounds, we gotta use prefixes to name them. So you have 1 sulfur, and you have 2 oxygen, dioxide. So the name is going to be sulfur dioxide. Now let's look at another one, N2O5. This also represents a molecular compound because nitrogen is a nonmetal. Oxygen is also a nonmetal, so we gotta use prefixes to name them. You have 2 nitrogen, that becomes a dinitrogen. And you have 5 oxygen, pentoxide. So you name this as dinitrogen pentoxide. Now let's look at the last group of binary compounds, which are binary acids. So in order to have an acid, there are 2 requirements. First, the formula of binary acids start with a hydrogen, with an anion, with a nonmetal. And also, the second requirement is that you have to have a solution of that compound. So you either say a solution of HCl, or you use this AQ, which represents aqueous, meaning that it has been dissolved in water. So in order to have an acid, we have to have water. So to see if a compound is an acid or not, first of all, the formula should start with hydrogen. and then water should be present. So meaning that we said you have a solution of that compound, or we use aqueous, the symbol for aqueous, to show that it's a solution. Now, only if you have these two requirements, you have an acid. So if it is an acid, your binary compound is an acid, the naming is different. So in order to name a binary acid, you start by using the word hydro, which is a prefix. That's followed by the root of the second element and add an X suffix. And then you add the word acid. So for example, HCl in an aqueous form, this is an acid because the formula starts with hydrogen. It's an aqueous form. So in order to name this, you say hydrochloric acid. Now, if you had HCl and it wasn't in an aqueous form, it's not an acid anymore. You just call this as hydrogen chloride gas. So pay attention to the difference between these two. Now, let's try to name this compound. So assuming that it's a solution, it becomes an acid because the formula starts with hydrogen. It's in an aqueous form. So the name for this compound is going to be hydro. So the name for this compound is going to be hydro sulfuric acid. Let's look at another one, assuming that it's a solution of HI. So since it's a solution of HI, the formula starts with hydrogen and it's in an aqueous form. This becomes an acid. So you name this as hydro iodic acid. Let's look at more examples. H2SE, assuming that you have a solution of this. The formula starts with hydrogen. It's in an aqueous form. It's binary, so this is a binary acid. To name this, it's going to be hydroselenic acid. A solution of HF becomes hydrofluoric acid. So let's just review the naming for binary compounds. So for binary compounds, we have two types, binary ionic and binary molecular. So if your compound is binary molecular, composed of two nonmetals or a nonmetal and a metalloid, you use prefixes, mono, di, tri, tetra, to name them. Now, if you have a binary ionic compound, that's when your compound composed of a metal and a nonmetal. Two things could happen. If your metal is a main group metal, you just use the name of the metal plus the anion's name, which ends with IDE. And if your metal is a transition metal, which has a variable charge, you gotta mention the charge of the transition metal with Roman numerals in parentheses first, and then that's followed by the name of the anion, which ends with IDE. Now there was another way of naming them, which we don't really need to know this one. We're just gonna focus on the systematic naming. Now the last group of binary compounds are binary acids. So if the formula starts with hydrogen and then follows by a nonmetal, if it's in an aqueous form, meaning that there is water, it's going to be an acid. So you start with the name with the prefix hydro, you add the suffix "-ek", followed by the word acid. But if your binary compounds that starts with a hydrogen and follows by a nonmetal is not in an aqueous form, it's not a solution, you just name it as hydrogen followed by the name of the nonmetal. So let's do a couple of examples. You want to name this compound CuCl2. This is how you want to approach this. This is a binary compound, first of all, correct? You have copper and chlorine, 2 elements, it's binary. Now, is it binary ionic or binary molecular? Is this binary ionic or binary molecular? This is ionic because it's composed of a metal and nonmetal. So this is binary ionic. Now, is your metal main group metal or transition metal? Yes, so we have transition metal, meaning that the charge is not fixed. We gotta figure out what the charge of the metal is, transition metal, and use Roman numerals to name this. Now, so as soon as you see that you have a transition metal, you have to find the charge of the transition metal. Now let's find the charge of the transition metal. So you have 2 chlorides, and each chloride is a -1, which gives you a total of -2, plus charge of the transition metal gives a net charge of 0. So if this is -2, it means your copper has to be +2. So we name this as copper 2 chloride. So let's look at another example, C3N2. This is a binary compound because it's only composed of copper and nitrogen. Now, is this binary molecular or binary ionic? Molecular or ionic? So it's a molecular compound because carbon is a nonmetal, nitrogen is a nonmetal too. So in order to name this, you gotta use prefixes. So you do tricarbon dinitride. So ICO3, again, it's a molecular compound. Iodine is nonmetal, chlorine is nonmetal. So we gotta use prefixes. You have 1 iodine, so that becomes just iodine, 3 chlorines, trichloride. For a solution of HCl, it's a binary compound, hydrogen nonmetal, and it is in an aqueous form. Water is there, so it considered as an acid. So you call this as hydrochloric acid.